your electric field formulas, and then magnetic field I didn't still write, that are also same. Clear?
Yes, sir.
Yes, sir.
So if you learn one, you don't need to learn the other. So did we get the formula for this? This is also your delta U,
U.
Yes, sir.
right? So we can write your delta U as,
P final.
no, my game
QF
is
minus UI
go back, GM into 1 by
minus GMM by
minus
minus
M by R.
by
by R.
1 minus 1 by R2. Okay, we got this, and then from infinity we bought it and placed it R, so 1 by infinity became 0, no? Understood? I did the derivation yesterday, right?
Yes, sir.
Hmm. Now if I take a finite line of mass, then your electric field in X is,
G
Lambda
lambda.
A by sin alpha plus sin beta.
and your EY is G lambda by
A by cos alpha minus cos beta.
Sir, in Arena book it is given as G lambda by A into cos beta minus cos alpha, sir.
That's okay, right? Forget about your this thing. If you get minus sign, the initial direction which you have taken is opposite to this. That's all.
Okay, sir.
Understand?
Yes, sir.
So infinite line,
2G lambda by
your
EX is equal to
2G lambda by
A.
A. Thin ring. Your electric field is G M X divided by
X
X
square
square
plus
plus
R square whole power 3 by 2.
2 by 2. Mm. Next is your thin disk. Your electric field is 2Gm divided by R square. 1 minus X divided by
2 over
under root of,
R square plus R square. So small
yeah.
m
But can be
GMM, right?
written as your cos
Cos
theta.
theta.
Yeah.
GMM.
What is it?
G capital M and small m, right?
No. M, why another M comes?
Okay, okay. Yeah, okay, sir.
Previously these are written it as F, no? Yeah. So here no M
Yeah,
is there
that's
if
my
it
doubt.
is GMX divided by X square plus R square whole power 3 by 2. So E is equal to Gm by R square into 1 minus X by under root of X square plus R square. Now, solid sphere. E
Is equals to GM by
inside I want. For a solid sphere, E inside.
GM by A square, right?
So it will be minus
Minus GM by 2 R
by
cube.
M by R.
Okay, no, I'll do one thing then. First tell me E outside. First you tell me E outside.
M by A
GM by
square.
A square.
Em divided by A square. What happens to your potential outside?
I-
surface.
Gm by r square
M by R.
and V is Gm by r square.
Minus GM by R.
Minus Gm by
R.
R.
R. Now you tell me, first you tell me V inside.
Minus GM by 2 R cube into 3 R square minus B square.
Hmm. Minus B square or X square. Yes?
Yes, sir.
Yes.
Now you tell me what is your E inside.
GMB by R cube.
GMB by R cube.
Understood? Clear?
Yeah, sir.
If somebody asks you what is my E and distance graph, okay, and this is your distance R, until you're from inside, how is your electric field going?
Linearly
Yes.
in a straight line.
And from there,
It goes
Down.
okay.
Yes, sir.
So this is how it will be. Now, yesterday I was telling you about your Gauss theorem, right? Now, see, Gauss theorem generally it is given in your electrostatics. Okay, so in electrostatics, left and right will use your Gauss theorem. Okay, so right now we will attribute this Gauss theorem in your gravitation as well, and we'll try to get your gravitation formula for your, I mean, electric gravitational field formula using your Gauss theorem. Okay, so what your says is this is not in your PU syllabus, but then I'm just telling you because it will be very easy. There's something called as your gravitational flux, which is given by field dot dA. Okay, so this is called as your gravitational flux. The amount of gravitational field in a given area is called as your gravitational. So what we do is Gauss law says integral Eg dot dA is equal to minus 4 pi g into mass enclosed. Okay, so now let us see what do we mean by this term. If we know this, then everything is done. For example, now let me take a solid sphere, this is R and mass m. Now, if I suddenly ask you, tell me at any point outside at a distance of x, what is your gravitational field strength? Then what you will do is, you will construct a surface with x as radius. Okay. Now, Eg into what is your area of this x as radius you have taken surface, no? So this surface is called as Gaussian surface. Understood? This is called as your Gaussian surface. Now tell me, what is your area of this Gaussian surface? Area of this Gaussian surface.
Pi x square.
4 pi x square. See, Gaussian surface should enclose this mass. So it is a sphere. No? This Gaussian surface which you have taken is also sphere, right?
Yes, sir.
See, this is a sphere, right? So you will enclose a sphere only by a sphere, no? Is equal to minus 4 pi g. What is the mass enclosed by this Gaussian surface? M, right?
Yes.
4 pi 4 pi gets cancelled. Eg is equal to gm divided by x square. Now look at your formula for any point outside. What is your electric field? Of course, we'll take a mod. Minus indicates the field is towards this. Okay.
Yes, sir.
We said the field is towards your mass. Is it the same thing which we have got doing the derivation?
Yes, sir.
We got gm by a square. No?
Yes, sir. A will look at the difference between Z.
Now, if this point is coming here on surface, point is coming on the surface, do it. Eg into, you have to take your Gaussian surface here. What is your area of the Gaussian surface?
4 pi.
4 pi r square is minus 4 pi g. What is the mass enclosed by this surface?
M.
Your Eg is gm divided by mass square. On the surface, is this the value?
Yes, sir.
Now, let's go inside. So when I'm going inside, at any distance x, I'll take a Gaussian surface. Okay, this is x. Eg into 4 pi x square, right, is equal to minus 4 pi g into mass enclosed by this Gaussian surface is how much? For 4/3 pi r cube, the mass is m. So 4/3 pi x cube, how much is your mass? M into x cube divided by r cube.
Yes, sir.
Yeah,
Yes, sir.
understood?
Yeah. Yes, sir.
M into x cube divided by r cube. 4 pi 4 square, this goes. G m x divided by r cube. Is this something you got inside?
Yes,
Understood your Gauss theorem? Understood your Gauss theorem?
Yes, sir.
Is it clear?
Yes.
yes, sir.
Okay. What we will do is, I'm going to take a spherical shell. A spherical hollow shell. What do I mean by hollow? It has mass m and radius r. Inside there is no mass. The mass is only on the outside, right?
Yes, sir.
So now, using Gauss theorem, E outside, E surface, and E inside, you tell me how much it is. Radius is now. The radius is a spherical hollow shell. See, outside means at any distance from center, at a distance of x you take. What will you do? You will construct a Gaussian surface with x as your radius. Clear? That is your step 1. Step 2 is Eg dot dA is equal to minus 4 pi G mass enclosed. Eg into spherical hollow shell means it's a 3-dimensional body. So it will be 4 pi x square is equal to minus 4 pi G into what is the mass enclosed by this Gaussian surface? Total mass m only. Understood? So see, what I'm basically asking is, see, this is 10 kg. Now I'm going to take a space around this. I'm asking what is your mass enclosed around this space? What will you tell? 10 kg only, no?
Yes, sir.
Then what's so confusing in that? Mass enclosed means inside this Gaussian surface, how much mass is there?
Okay, okay. Got it, sir.
M.
Understood?
Yes, sir.
Mass enclosed. So how much is the mass is inside this Gaussian surface? That is what is called as mass enclosed. So the mass enclosed in the Gaussian surface of ray x, if you have constructed, is total mass, isn't it?
Yes, sir.
Yes, sir.
So E outside is how much?
G m by x square.
Hmm. Now come to surface. Tell me how much it is.
So it's Eg into 4 pi r square.
Do it and tell me how much you will get.
G m by r square.
R square.
Good. Now
Is it 0?
it is 0. Fantastic. Because if I take this as your mass is only for hollow sphere, right?
Yes.
Mass is only on the radius. If I take my Gaussian surface inside of radius x, what is the mass enclosed by this Gaussian surface inside? 0. But now tell me, what will be your potential inside?
Zero, sir.
No.
No.
You cannot use, Gauss theorem for your potentials. It's only for your flux.
Okay.
Correct? Okay. Do me your potential outside. In the first case, get me your potential.
Sir, inside it will be minus 3 gx.
No, that is for solid sphere. Amma. This is a hollow sphere. No,
Oh, yeah, okay.
hollow means there is no mass. No mass. Everything is outside only. Inside you don't have any mass. Okay,
Yeah.
understood?
Yes, sir, yeah.
So V out will
Is
be
equal to minus dV by dr, isn't it? Yes.
Yes.
yes, sir.
Yes, sir.
So I'm asking potential from this dV is equal to minus E dot
dr.
dr, or V is equal to integral minus E dot dr
dr.
minus integral outside, if you take it, is Gm divided by x squared dx, isn't it?
Yes, sir.
It will be
V
Gm
minus
by
Gm dx.
x. So V outside is Gm minus minus Gm divided by x. Now tell me this. What is your V on the surface? Minus Gm by r norm. Yes?
Yes, sir.
Now I'm trying to rub this because I'll have some space. Your V is equal to integral E dot dr, minus integral 0 dot dr if you go inside, right?
Yes, sir.
Yes, integral 0 dot dr we are taking. So what happens to this value? It will be integral 2 dx. For example, let me say 2, you will get it out, and dx you will do integration, x you will get, right?
Yes, sir.
Correct?
Yes, sir.
So, but instead of 2, there is 0 here.
Yes, sir.
So there should be some value, right?
Yes, sir.
Yes, sir.
Because if I get my E, which is equal to minus dv dr, if I take a constant velocity, for example, d by dx of 2 is how much?
0.
0.
0.
D by dx of, let me say, some 100 is how much?
0 only.
0. So if I do integration, integral of 100 is equal to integral 0 dx, right?
It's a
So
constant.
that means even if this is 0, there is some value here.
Yes, sir.
Yes, sir.
Understood?
Yes.
So electric, magnetic, gravitational field 0 doesn't mean your potential should be 0. Okay?
Yes.
Potential will be constant. So when you differentiate potential, you will get the magnet, gravitational field to be 0. Understood?
Yes, sir. V is something constant.
So your V is constant, and that will be equal to minus divided by R. Understood? So for a hollow spherical shell, whatever potential you have on the surface, the same potential you will have it in
Inside.
inside also. Understood the logic?
Yes, sir.
So d by dx of 2 will be 0. So d of 2 is equal to 0 into dx. Taking integral both sides, 2 integral 0 dot dx. So if you look at this, it is like v is equal to integral e dot dx, right?
Yes.
So
Yes.
v will have some value. Okay. So a gravitational field 0 doesn't mean your potential will be 0. It still has a value, but it's a constant value. So if you are here, here, or here, or here in a hollow spherical shell, the potential is
Minus GM by R.
Minus gm by r.
okay. Understood? Clear?
Yes.
Have you taken this down?
Yes, sir.
Yes, sir.
1 minute.
See, this also we can normally do. Yesterday in the class I have done, no, that we have to do. Take somewhere point, consider a small element dm here because of this how much, and then do it. Okay. But PU level, I don't think you have this derivation. So I'm telling you this using your Gauss theorem. Okay. So I think now any structure I give, sphere or anything, you can use for three-dimensional things. You use your Gauss theorem. Okay. Understand?
Yes, sir.
Three-dimensional thing, you use your Gauss theorem.
Yes, sir.
Shall I go to the next one? Shall I go to the next one?
Yes, sir.
See, the next one is your null point. Okay. Now, what do we null point? See, if I take a mass m1 here, and if I take a mass m2 here, these are at a distance of d. Now, see, this mass has your gravitational field in this direction, and this mass has a gravitation in this direction, right?
Yes.
Hello. So whenever these gravitations are in this direction, can I say somewhere in the line between those two, they will have zero gravitation field? See,
Yes, sir.
for example, imagine this to be your Earth, okay? And imagine this to be your moon. Moon is pulling Earth towards it, and Earth is pulling moon towards it, right?
Yes, sir.
But see, your satellites are being spaced somewhere that the satellite is not being pulled by the Earth and it's not being pulled by your moon, right? Their satellites are rotating around the Earth in between Earth and moon, no?
Yes, sir.
Yes, sir.
Then the satellites are staying there constantly for 10 years, 15 years, right? In the space, correct? So from Earth, we have found out a distance where the gravitational pull of Earth and your gravitational pull of moon are equated. So here the net gravitation is 0. So those points we call it as null point. So these null points are the places around your Earth where your satellites are launched. Understood?
Yes, sir.
Yes, sir.
And you may think the satellites will be going around the Earth. No, if this is India and if you have launched the satellite and the satellite went into your geostationary orbit exactly onto India, so this and this will yes. So with respect to India, this satellite is always above India. Okay. Maybe you may be imagining my satellite is rotating around the Earth. No, this point and this point are always in rest with respect to each other. Okay,
Okay.
that's how our GPS work.
Okay, sir.
So if it's an Indian satellite will always be above the Indian subcontinent only. So if you are looking at your, if you are sitting in your satellite and looking at your India, every time when the satellite is going, India will be only seen. You cannot see any other country. Okay.
Yes, sir.
Yes, sir.
So that is called as your null point because at this distance, your net gravitational field which is there is 0. Now at this point, I'm going to take this point as x. Okay. So what is your gravitational field strength because of this planet M1 on this place? Gm1 divided by
X.
x square, amma. Gravitation field strength, amma.
Yes, sir.
And E2, that is because of your M2 at this position,
GM2 by X square.
M2 divided by
D
d
minus.
minus x whole square, isn't it?
Yes,
I
sir.
said if these two are equal, then that place your net gravitational field will be 0. So Gm1 divided by x square is equal to Gm2 divided by d minus x the whole square. G gets cancelled. Find x, it will be d divided by under root of m2 divided by m1 plus 1. Understood?
Yes, sir.
So x is from mass 1. Clear?
Yes, sir.
Have you taken it down?
Yes, sir.
So put your heading as null point and then write it x is equal d divided by under root of m2 by m1 plus 1. So this is your null point as 1. You have to be very careful because if he's asking distance from m2, then you have to do d minus x, okay?
Yes, sir.
Now, see, we have gravitation potential energy to be minus g m1 m2 divided by r, right? Now, for example, I have three particles. I have three particles, and the distance between the three particles is r1, r2, and r3. Let me say. Okay. That will be my gravitation potential because of these three masses, which are m1, m2, and m3. So the total potential energy of the system is minus g taken common m1 m2 divided by r1 plus m2 m3 divided by r2 plus m1 divided by
R3.
understand.
Yes, sir.
So now if they ask five particles, you can do, right?
Yes.
M1, M2 divided by R1 plus M2, M3 divided by R2 plus M3, M4 divided by R3 plus M4, M5 divided by R4 plus M5, M1 divided by R5 plus you will get. So what we say is if they are N particles, the number of pairs will be n into n minus 1 divided by 2. So if you have 5 particles, how many pairs
10.
you will get? 10 pairs. 1, 2, 3, 4, 5. 1 on 2, 1 on 3, 1 on 4, 1 on 5. 2 on 3, 2 on 4, 2 on 5. 3 on 4, 3 on 5, and then 4 on 5, right?
Yes, sir.
You got 10.
Yes, sir.
So this is how your gravitation potential energy for a system of particles will be there.
Yes, sir.
Okay. So their maximum they'll go for only 3 pairs. This calculation itself will take time. Clear?
Yes, sir.
Now let's go to the next one. See, what is your the next one is gravitational potential energy of Earth. Let's see, since we have studied for a planet of Mars M, let us come to Earth. Now tell me, what is your gravitation potential energy on surface?
Gm by R square.
Gravitation potential energy.
Small m by R square. Sorry.
Whenever you forgot your gravitation potential energy, remember your potential energy is equal to F into D, okay? So this is G M divided by D square into D. D gets cancelled. Understood?
Yes, sir.
You just remember the small tip, you will never forget this. Okay?
Yes, sir.
Hmm. So on the surface, it will be minus GMM divided by R. Now see what I will do for this. Divided by R into R divided by R, right? This will become minus GM divided by R square into M into R. What is GM by R square?
G.
G.
Acceleration to gravity.
Hmm. Sure. Did you arrive at your formula potential energy is equal to mgh? Yes?
Yes, sir.
Clear? Now, at a height h, what will be your potential energy? Minus m divided by
H.
R plus H.
r plus h. As simple as that.
Yes, sir.
Okay. So surface, you have minus gmm divided by r, or else minus mg r. If you go to a height h, you will have minus gmm divided by r plus h. Understood?
Yes, sir.
Now what I will ask is, what is the potential energy, no, what is the work done by an external agent in taking a body from the surface and placing it at height h? That's what the question will be. Okay. They'll ask, what is the work done by an external agent in taking a of mass of m from the surface to a height
H.
h.
So will it be potential energy at H minus the potential energy at the surface?
Correct. So your delta work done, or work done, is nothing but your delta potential energy, isn't it? So it is minus g m divided by r plus h minus g m divided by r. U final minus u initial, no?
Yes, sir.
So this will become plus. So GMM, if I take common, it will be 1 by R minus 1 by, yes.
Yes.
So work done in taking the body from the surface of the earth. So this is your center point, this is your R, and placing it at a distance h from the surface is GMM into 1 by R minus 1 by R plus h.
Yes, sir.
So only three formula we have learned today. One is your hollow sphere, what is your gravitational field and gravitational potential at outside, on the surface and inside. And then we have found out the null point between two bodies, right? And then we have found out your gravitation energy of Earth on the surface, how much it will be. And if you are taking the body to a height h, how much it will be. Understood? Then we have seen, if you have to lift a body from the ground to a height h, how much work you have to do. Clear?
Yes, sir.
So now let's go to a concept called as very important escape velocity. which we generally denote it with VE. Now, what do I mean by escape velocity? Escape velocity is defined as minimum velocity with which the body has to travel from the surface of the earth to escape the gravitational field strength of the earth. And minimum velocity with which the body has to travel to escape the gravitational field strength of Earth. Okay. So if this is, let me say, your Earth, there is a body here. With how speed this body should go so that it will escape the gravitational field strength, right? Now, see what I'm going to do is, from here onwards, extensively we will be using the concept called as, what is this?
Conservation of energy.
Good. So if I take a body here, the total energy of the body at A should be equal to total energy at the body at B, right? Correct?
Yes.
So now when I project a body with escape velocity, it is reaching your B. From here, there is no potential energy of your kinetic energy of the body here, isn't it? Because if you need potential energy, it has to be attracted to Earth. So when it is going to this point, is not being attracted by the Earth, right? Yes or no? So this body does not have any potential energy, right?
Yes, sir.
Yes, sir.
And when it goes here, all the energy it will use to come here. When it comes here, your body will be around your Earth, or it can escape into space also. Okay. So your total energy at A should be equal to total energy at B. Okay. Now let me say until here only my body has a velocity. At this point, let me say my VB is 0 and my VA, let me take it as VE. What is your potential energy here? Because total energy is potential energy at A plus kinetic energy at A is equal to potential energy at B plus kinetic energy at B, right?
Yeah.
B is 0, right? So this goes off. Correct. VB is 0 now.
Yes, sir.
This has went into a place where Earth cannot pull this body. So what happens to your potential energy? Zero.
Yes, sir.
Now what is your kinetic energy at this point?
Half into
V E square.
yes, sir.
Yes. What is your potential energy on the surface of Earth?
Capital small m by r.
Minus G capital small m divided by
R.
is equal to
0.
From this, you get your escape velocity as clear.
Yes, sir.
Understood? So if you want multiply and divide inside, it will become under root multiply and divide with r naught.
Yes,
D m by r square is small g. This is radius of Earth. This is acceleration due to gravity on Earth, everything is constant inside. So if you calculate it, you'll get close to about 11.2 kilometers per second. Understood?
Yes, sir.
So any body, all the rockets which are going into space will go with the speed. Okay. But they cannot go with the speed. So boosters are given. Every time it will boost the body to go up. Okay. Understood? Clear?
Yes, sir.
Now tell me, instead of on the surface of the earth, if I want a body is, let me say, at a height h, is it over? Can I go to the next one?
Yes, sir.
So now instead of this, if I take this as the surface of your earth, your body instead of on the surface, it is somewhere at a height h from your surface. From this, I will escape now. From this point, I want my body to escape now. What will I do?
We have to take conservation of.
Here, conservation of moment. And let me say at this point, it is escaping, right?
Yes, sir.
So at TEB, your VB will be,
0.
Zero.
your VA will be.
VE.
So total energy at A should be equal to total energy at B. So potential energy at A plus kinetic energy at A should be equal to potential energy at B plus kinetic energy at B. Your kinetic energy at B goes to 0, potential energy at B goes to 0. You understood the concept why it is going to zeros?
Yes, sir.
At this point, Earth does not have any say on its body now. Okay? Because this body is escaping the gravitational field strength. Earth has this point. If you go there and if you dance also, Earth cannot do anything. Okay?
Yes, sir.
Yes, sir.
Understood? So think this Earth as your teacher. Think this line as your parents. Whatever you do in between your parents and me only, I can do something. If you are doing backside of your parent, I cannot do. That means you are saying my parent is in front of me. So whatever nonsense I do, you have to just keep quiet. Okay. So it is something like that. So Earth, it's a say only at this point. Beyond this point, if you go here, stand here, and your corresponding scolded it also, Earth cannot do anything. It will just weep silently because it does not have strength to do something on you. Okay,
Yes.
understood? So potential energy at here, how much is it?
Minus G capital M small m by R plus H.
Plus
Half M
m
E is
VE square should be equal to
0.
0. From this VE is equal to GM, no, 2GM divided by, correct?
Yes, sir.
In this escape velocity, we have case 1. If given velocity is less than escape velocity, okay? So given velocity is less than your escape velocity, what happens? See, escape velocity is, let me say, 11.2 kilometers per second number, right?
Yes, sir.
Now I'm giving a body only 1 kilometer per second velocity. What happens to this body?
It won't cross.
it will go to certain height and again falls down, right?
Yes, sir.
So if this is your surface of the earth and you are projecting it with some v, it will reach some height h and again it will fall down, right? Total energy A and total energy B. Tell me, what is your total energy at A? Surface norm. What is your total energy?
Minus G capital small m by
R
R
plus half mv square.
into
V square is equal to, what is your total energy at a height h?
minus G capital small m divided by H plus 0.
Plus 0. Because when it goes here, the velocity becomes
0.
0. So tell me your velocity now. Calculate this.
What should we calculate, sir?
Velocity, you have to calculate your velocity. M gets cancelled, right?
Yes, sir.
So take this guy that side. V squared divided by 2 is equal to Gm taken common. It will be 1 by R minus 1 by R plus H. So V is equal to under root 2 Gm into 1 by R minus 1 by R plus H. Clear?
Yes, sir.
Now he will ask, I am projecting a body with 1 kilometer per second. Then tell me at what height the body will reach. Okay. He will say, I have projected my body with 1 kilometer per second. Tell me at what height it will reach. Okay. Now the problem with this formula is G value you have to remember, M value remember, right? And R value you have to remember. Correct?
Yes, sir.
Now what he says in the question is, a body is projected with a velocity of 1 kilometer per second. At what height the body will reach from the surface given VE is equal to 11.2 kilometers per second. Okay. Then what we will do is, we have to convert whatever this is there into E and V, isn't it? Correct?
Yes.
We have to convert everything in terms of your VE and V, this whole formula. We know V is 2Gm divided by R, isn't it? Hello?
Yes, sir.
Your V is under root 2Gm divided by R,
Yes.
no?
Yes.
VE is under root 2Gm divided by R. Correct? And we got V is equal to under root 2Gm into 1 by R minus 1 by
R plus.
H. Right? Now see, VE square is equal to 2Gm divided by R, and V square is equal to 2Gm into 1 by R minus 1 by R plus H. Right? So I'll take VE square divided by V square is equal to, no, I'll want this one, no? Let's do this and then we'll rearrange it. 2Gm divided by R whole divided by 2Gm into 1 by R minus 1 by H. 2Gm gets cancelled. Here take your LCM. Okay. So you have 1 by R. Here take your LCM. It will be R plus H minus R divided by R into R plus H, isn't it?
Yes.
R. R gets cancelled. This becomes divided by H. Correct? So VE square divided by V square is equal to R by H plus 1. From this, R by H is equal to VE square divided by V square minus 1, right? Equal to R divided by VE square divided by V square minus 1. Clear? See, I have taken the two base equations. I have taken the two base equations and I'm just rearranging the terms, okay?
Okay.
Did you understand this?
Yes, sir.
Clear?
Yes, sir.
Now, if your projected velocity is greater than escape velocity, so I am taking my body here and I'm let this be A. I am projecting this body. Since it is greater than escape velocity, after B also it will travel with some velocity, right?
Yes, sir.
Yes or no? So this is the velocity with which it will go to infinity. Okay. For example, I'll just tell you in a simple sense. 11.2 kilometers per second is your escape velocity, right?
Yes, sir.
Now, if I have projected it with 24 kilometers per second, now I'll ask you with what velocity will it go to infinity? Okay. So this is my escape velocity. This is my V. Now I have to get a relation of your V infinity square in this case, right?
Yes.
Understood?
Yes, sir.
So first take your total energy again. Total energy at A is equal to, what is your total energy at A?
Minus G capital M small m divided by square.
R plus half mv square. What is your potential energy beyond B?
0.
What is your kinetic energy?
Half m v infinity square.
Correct. M gets cancelled. Multiply everything with 2 minus 2 GMR is equal to V infinity square. Okay, we'll do one thing.
Plus v is equals to v.
Plus V square is equal to V infinity square, right? Correct. Now,
Yeah.
what is your 2 GM by R?
PE square.
Correct. So this becomes V square minus
V square.
is equal
Infinity
to,
square.
so V infinity is
Under root of v square minus v square.
okay.
Yes, sir.
So this is the velocity with which your body will go to infinity. This is the velocity with which your body will go to infinity.
Yes.
Clear?
Yes, sir.
This is to escape your Earth. Okay. So I'm just recapping what we have just done. I'll just recap what we have done. We have seen what your potential and gravitational field strength is for hollow spherical shell we have seen your Gauss theorem, and we have applied this Gauss theorem for a hollow spherical shell, and we have seen the gravitational field strength and gravitational potential. Then we have seen your null point. Then we have seen your gravitation potential energy for a body on the surface of the earth, and if it is being taken to the high, correct?
Yes, sir.
Then we have seen what your basic escape velocity definition is, and we have derived an equation for your escape velocity, which is under root 2 gm divided by r, right?
Yes, sir.
And then we have seen if the body which is being projected into the space, if its velocity is less than escape velocity, what happens? Escape velocity, it will go, right? There is no doubt in it. If
Yes,
it is greater than escape velocity, what happens? Clear?
yes, sir.
Now, see how we have done is, if this is your earth, let me say, for using Newton's law, we have given a force. We have given and we have attributed your gravitational field strength. We have attributed your gravitational potential. We have attributed your potential energy, let us be E, right? We have attributed the work done in bringing us, right? And we have talked about what is your velocity with which a body should, get to get out of the planet. What should be your velocity, right?
Yes,
These are the things which we have learned. Now let's talk about a body which is already in space. For example, if this is your Earth and your satellite is somewhere here, this satellite is revolving around your Earth.
yes,
Now, let me say this is a height small r. Okay. I clearly said this body satellite of mass m, and this is your capital M. If it is rotating direction in a fixed distance r, that means whatever your gravitational pull is there, it is acting or is equal to your centripetal force, isn't it?
yes, sir.
So now put your heading as satellite, orbital speed of satellite. Orbital speed of satellite. So what do we mean by orbital speed of satellite? The speed or the velocity with which the satellite is revolving around your Earth, okay, in a radius r is called as your orbital speed of satellite. So mv squared divided by r, can I say, should be equal to g m square.
Yes,
So r m gets cancelled. From this, v is equal to under root g m divided by r, or else this will be under root gm divided by, if this is your r and this is your h, it will be r plus h. Understood?
yes, sir.
Now ask, what is the time period of revolution of this satellite? What is your basic time period formula?
2 pi by omega.
2 pi by omega. So if I can find my omega and I place it here, I get my time period of the satellite.
Yes, sir.
To get my time omega, I'll take the same equation. mv square by r is equal to gmm divided by r square. R m gets cancelled. V square is equal to gm divided by r, but v is r omega. R square omega square is equal to gm divided by r. From this, omega is equal to under root gm divided by. Understood?
Yes, sir.
So place it here. 2 pi under root r cube divided gm. Clear? If you square this, see t square is equal to 2 pi r cube, 4 pi square r cube by gm. What is this?
So, third law of Kepler
Fantastic.
is actually proportional to R cube.
Clear?
Yes, sir.
No doubt in this, right? This r cube may be r plus h whole cube, okay?
Yes, sir.
So that's okay. It depends. Now, see, what is your escape velocity?
11.2 kilometers per second.
No. This formula. Under root
2g.
2gm
GM.
divided by r, right?
Yes,
Yes,
sir.
Your escape velocity is under root 2gm divided by r. Under root gm by r is
E.
E. Orbital speed.
clear.
Sir.
So that's your relation between your orbital speed and your escape velocity. Your escape velocity is root 2 times of your orbital speed.
Yes.
So which is more, escape velocity is more or orbital speed is more?
Escape
Escape
velocity.
velocity.
Escape velocity is more.
Later.
Clear?
Yes, sir.
So did you take orbital speed, time period, and relation between your escape velocity and orbital speed, right?
Yes, sir.
Have you taken this down? Shall I go to the next one?
Yes.
Yes, sir.
I don't know if you're writing it or not. So today what we have learned is hollow sphere,
Gauss theorem.
E outside, Gm divided by R square, V outside,
Minus GM by X.
surface,
GM by capital R square.
V surface,
Minus GM.
inside,
Low.
V inside,
Minus GM by capital R. EG into minus 4 pi.
okay?
Yes, sir.
And now you know how to apply your Gauss theorem for everything,
Yes.
correct? So next what we have seen is your null point. X is equal to D divided by
under root of m1
M2 divided by M1 plus 1. Okay. X is
From
distance
mark 1.
from
mass 1.
M1. Remember that very clearly. Then escape velocity is equal to under root. No, not escape velocity. Potentials we have studied, no?
Yes, sir.
Yes, sir.
Potential energy on surface.
Minus G capital M
Minus G
by
capital
R.
M by R.
Hmm. Potential height
Minus G
Minus G
capital M
capital
small m by R plus H.
by R plus H. Delta potential energy, height and surface.
G capital M small m
Hmm.
into 1
Q
minus R
1 plus R
minus 1 by R plus L.
1 by R.
See, this is your final, this is your initial, okay? Final minus initial. Understood?
Yes, sir.
Yes, sir.
Clear? If you have any doubt, use these basic fundamental formulas, get this value, and then take your delta PE, okay? Potential energy is always minus, okay?
Yes, sir.
Is it clear? Um,
Escape velocity.
hmm. So velocity is equal to under root 2
By
gm divided
R.
by r,
Equal to
or
under root 2 small g by R.
small
R.
2g. Okay. So for any planet, okay, this is for any planet.
For Earth, it is 11.2 kilometers.
7.6
For Earth, it is orbital speed.
under root 2 G
G
by R.
under
Small r, not capital R, okay? R plus H norm.
yes, sir.
Yes, sir.
So small r. So or else it is
VE divided by root 2.
okay. Time period of your satellite.
2 pi into under root of R cube divided by GM.
Under root R plus H whole cube divided by GM. Okay. Clear?
Yes, sir.
Now, sometimes they will ask, what is the kinetic energy of your satellite? Okay. What is your kinetic energy formula?
Half C square.
Satellite, no? So orbital speed you will get, right?
Yes.
Yes.
But what is V naught square?
GMR by R.
So half G capital M small m divided by
R.
R. Correct?
Yes, sir.
So kinetic energy of your satellite is GMM divided by 2R. Understood? Understand? Now, what is your potential energy of your satellite? Minus GMM divided by R. So, what is your total energy of your satellite?
Kinetic plus potential.
So, add it. How much you will get? Tell me. My GMM divided by 2R. Half 1. If you remove half from 1, how much?
Half.
And it is minus 1 plus half, so minus half. Okay?
Yes.
Understood? So from this, total energy of your satellite is equal to minus kinetic energy of your satellite, because GMM divided by R is,
Kinetic energy.
or take only this term. What is it?
Kinetic energy.
Gmm by R is what? Minus Gmm by R is what?
Potential.
So it will be
Potential energy by 2.
this for day. We will be using this formula in electric fields, moving charges, magnetism, magnetism in matter, atomic physics, also atoms also will use the same formula. Understood?
Yes, sir.
Anywhere in your physics, total energy of the system for rotating with heliocentric systems, total energy is potential energy by 2 or minus kinetic energy. So total, and we'll write the formulas of that also. So kinetic energy of satellite is equal to Gmm divided by 2R. Potential energy of the satellite is equal to minus Gmm divided by R. Total energy of the satellite is equal to minus Gmm divided by 2R, or kinetic or potential energy by 2. Clear?
Yes, sir.
Yes.
So shall we solve some problems?
Yes, sir.
Two bodies of masses m and 4m. Two bodies of masses. Two bodies of masses m and 4m are placed at a distance d, or placed at a distance, full stop. The gravitational potential, the gravitation potential, the gravitation potential at a point where the gravitation potential at a point where the gravitational potential at a point where gravitational field strength is zero. The gravitation potential at a point where gravitational field strength is zero. So what he says is, this guy, he takes a mass m and he takes a mass. So he says the distance between these two is d. So it seems there is a point somewhere where your gravitational field strength is zero. At that point, let me say that point is the distance of x from here. At that point, you have to find your Vg. Go ahead.
Sir, x will be d by 3.
Yeah, x3, correct. Your potential is, if it is d by 3 from here, this distance is
m square by 3. 12 g m square by 3.
y m square you got. What is your potential formula?
G capital
By
by r is
so because of this mass, here your gravitation potential is minus gm divided by x. Because of this, here it is plus minus g into 4m divided by d minus x norm. Correct? This is minus 3gm divided by minus d by 3 means this will become 2d by 3. 2d by 3 goes up means
There will be
well,
minus
6.
9 gm by d.
by d. So this is minus 9 gm divided by. Clear? Is it clear?
Yes, sir.
Do you have your advanced book? Do you have your advanced book?
So,
Your advanced book material.
Yes, sir.
JEE Advanced Volume 3. You have system of particles and gravitation, right?
Yes, sir.
So open that. Page number 125. Page number 125. Question number 52. Advanced Volume 3, 125, question number 52. If g is acceleration due to gravity on the Earth's surface, the gain in potential energy of the body at a height equal to 3 times the radius of r of the Earth will be. H is 3 times of r. So he is asking the gain in your potential energy. Calculate your, what is your potential energy on the surface?
Minus G capital small and R.
By so what is your potential energy if the height is 3 times r? The
So minus
potential energy on the surface is minus gm divided by r, isn't it? Correct? If it is at a height h, right?
Yes, gm by r plus h.
So is it 3G capital and small and by 4R?
See, once again, I'm telling you the concept. Listen very carefully. He clearly says that the particle is a distance of 3 times the radius of Earth, right?
Yes, sir.
So this particle is somewhere here. at a height equal to 3 times the radius of Earth at a height. So this is R. From here it is at
3 hours, so the total distance is 4 hours.
potential on the surface you already know. Potential at a distance of this you already know. Do it.
3 by 4 G capital M small m by R, which is 3 by 4 mgr.
Minus.
It's plus
Why you get plus?
3 by 4 mg capital R.
Why you will get plus on?
It was there in the formula also.
Which question did I tell you to do? 52, huh?
Yes, sir. 52nd question.
Okay. Yeah, I'm looking at 51 and I'm getting confused. 52. Correct. Do it. 3 by 4
mgr.
mg capital R.
Is it minus 3 gm by R?
Minus
3 gm by R.
a particle of mass m is placed at the center of a uniform spherical shell of mass 3m and radius r. The gravitation potential on the surface of the shell is directly minus 3 gm by r only, no? No need to do also, right? Hello?
Yes, sir.
The formula we already know on the surface it is minus gm divided by r, no?
Yes, sir.
So m is 3m, no?
So in the back it's given minus 4 GM by R.
Minus 4 gm by R.
That is your potential due to your 3m on that point. Acha, a particle of mass m is placed at the center. Okay. If a part, 1 second. If a mass m is placed at the center, right? Because of this mass at this point, what is your potential?
Minus gm by R.
Minus gm by
R.
r. So this is because of smaller mass and this is because of your bigger mass. So total is?
So addition will become minus 4.
Yeah, do the addition. I didn't see the center mass. See, okay, see, I'll give you a question. See, there'll be something like this. What they'll do is, they'll put and then another spherical mass of 3m, another spherical mass of, let me say, 5m. Okay. He says the radius of the first spherical mass is r and the radius of next spherical mass is 2r. Now, if he asks the potential at this point, let me say A. Okay. Did you understand? One spherical mass of 5m.
You have to add all three of them.
So this, because of, let me say m, this I'll take it as 1, 2 and 3. Potential because of 1 at A plus potential because of 2 at A
Plus potential.
plus potential because of 3 at A. What is your potential because of 1 at A?
Minus GM.
Plus, what is your potential because of 2 at A?
Minus GM by R. 3M by.
What is potential because of your, see, this distance is R only, no?
Yes, sir.
Because of this, the potential
Minus G 5M by R.
by,
R.
from here to here, Amma.
Yeah, 2R.
2R, no? Clear? If he gives another shell, then you again do it. Now, for the same point, this is mass m, 1, 2, 3. If A is here, point, okay? The radius is r, this radius is 2r. Let me say midpoint between these two. So how much will it be?
3 by 2.
Now what is your potential at A?
So B potential of 1 at A plus potential.
Now this remains the same. Tell the second step.
Minus GM by 3 by 2R.
Good.
Minus 3M divided by 2R.
Good.
Plus minus 3 whole divided minus
Distance is
minus 1 by 2R. Because it's backwards.
2r. This point is inside the third spherical shell. So this, because of this, the potential will be because of no.
Yeah.
Understood?
Yes, sir.
Because this point for this shell it is outside, right?
Yes.
For this point mass it is outside. For this it is inside. So it will be this. Clear?
Yes, sir.
$64. 64. Acceleration due to gravity on moon is 1/6 of acceleration due to gravity on Earth. So G of moon is 1/G of Earth. If the ratio of densities of Earth and moon is rho of Earth divided by rho of moon, 5/3, you have to find out radius of moon in terms of radius of Earth. What is your G formula?
Gm by r.
Gm by r square, amma. So G divided by r square. What is your mass in terms of volume mass density?
Rho into volume.
So this will be G by r square. Rho of earth, let me say GE, into volume is 4/3 pi r e cube.
Yes, sir.
So this gets cancelled. This is G rho e 4/3 pi r. Yes.
Yes.
Correct. So now see, GE is directly proportional to rho e and RE. You got your relations?
Yes, sir.
Yes. So D divided by GM is equal to rho E RE divided by rho M RM. So GE divided by GM is how much? Rho E divided by rho M is?
5/3.
So RM is equal to okay.
Yes.
Okay. Do this question. If the mass of the planet is 10% less than Earth, if the mass of the planet is if the mass of the Earth is if the mass of the planet is 10% less than that of Earth, and the radius 20% greater of Earth, and radius 10%, 20% greater than that of Earth, the acceleration due to gravity of that planet is the acceleration due to gravity of that planet is. Shall I repeat the question? If the mass of the planet is 10% less than mass of the Earth, and radius of the planet is 20% greater than the radius of Earth, then acceleration due to gravity on the planet will be.
So you want the answer in terms of?
In terms of GP, in terms of GE, is it equal to how many times of GE?
So 0.625.
Can you tell me in P by Q form? Because the answers are in P by Q form.
Okay, so one.
See, mass of the planet is 10% less than mass of the Earth. That means mass of the planet is how much?
3/4. So is it?
9/10 ME.
9 by 10 times of ME. your radius of the planet is 20% greater than your RE, 6
1.2 R.
by RE. So he's asking GP is to GE, right? We know G is equal to GM divided by,
R square.
so GP divided by GE is equal to MP divided by ME into RE divided by RP
Whole square.
whole square. So MP is how much? 5 by 10 of ME divided by ME. RE divided by RP is
1.
6 by 5 times of RE, right?
Yes, sir.
ME, this becomes 9 by 10 into 25 by 36, isn't it?
Yes, sir.
5 is 5 by 10 of GE. Uh, 5 by 8, no? 2 4 is 8, no?
1.6.
5 by 8 of GE. Done?
Yes, sir.
The escape velocity from Earth is the escape velocity, the escape velocity the escape velocity of a body from Earth is 11.2 kilometers per second. Is 11.2 kilometers per second. Full stop. If a body is projected with a velocity, if a body is projected with a velocity twice of escape velocity, twice of escape velocity, the body is projected with twice of escape velocity, then the velocity of the body at infinity is, then the velocity of the body at infinity is.
Is it under root 3 VE? Under
Correct. Your V infinity is under root of V square minus V E square. It will be root 3 V.
so which is approximately 19.32.
Huh. Next, a body is dropped from a height h. A body is dropped from a height h equal to n times the radius of Earth. N times the radius of Earth. If G is accelerated gravity on surface, if G is acceleration due to gravity on the surface, then the speed with which it reaches the surface is, then the speed with which it will reach the surface of the Earth. The answers are in terms of acceleration due to gravities. The answers are in terms of G, R, and N.
So is it under root 2 n g r?
No. See, this is your height, which is equal to nr, right?
Yes.
Let this be A, let this be B. What is your total energy at A?
Potential energy.
G m divided by R plus nr, isn't it? So minus G m divided by R taken common n plus 1, right?
Yes.
What is your total energy at B?
Minus g capital small m by r plus half mv square.
Very good. So this V square we have to find, right?
Yes, sir.
So half m minus G m divided by R is equal to minus G m divided by R into n plus 1. M is cancel. V square by 2 is equal to G m divided by R minus G m divided by R into n plus 1, right? So V square is equal to G m divided by R, I'm taking common 1 minus 1 by n plus 1. N plus 1 minus 1 gets cancelled. 2 Gm n divided by R into n plus 1, right?
Yes.
Multiply and divided with R, so this will become 2GRN divided by, so from this V is equal to 2GNR divided by n plus 1. Mostly you must have done calculation mistake somewhere here. Understood?
Yes.
Is it clear? Shall we do another one? What should be the angular velocity? What should be the angular velocity of rotation of Earth? What should be the angular velocity of rotation of Earth about its own axis about its own axis, about its own axis, such that such that such that the weight of a person on equator, the weight of person on equator reduces to 3 by 5 times, reduces to 3 by 5 times of its present weight, of its present weight, given R is equal to 400 kilometers. So your options are in like 7.8 into 10 power minus 4 radians per second, 7.8 radians per second, like that. Okay.
Yes, sir.
That means we can study properly. Huh? See, weight at equator is equal to weight minus mr omega. Yeah, equator means theta becomes 0, right?
Yes, sir.
G minus r omega square. So
Yes.
weight of the person is 3 by 5 times the weight normally, right?
Yes, sir.
So mg dash is equal to 3 by 5 times your mg.
Yes, sir. So G is
G dash is 3 by 5 times of G. Substitute here, no? 3 by 5 G is equal to
R omega
omega square. R omega square is G
2 by
minus 3 by 5 is 2 by 5. 2G by 5. So omega is equal to under root 2G divided by 5R. This is equal to under root 2 into, we'll take approximately 5 into 3200 into 10 power 3, right? Because this is meter per second square, I have to convert this into meters, no? 6400 into 10 power 3, right? 5 ones, 5 twos, 4 if you take it, right? This is 16, right?
Yes, sir.
So under root 1 by 16 into 10 power
6.
5.
Yes, sir. 5.
So if 10 power 6 means we could directly get it, right? 10 power 3. So I'll take this as 10 by 16 under root 10 power minus 3 outside.
Sir,
Hmm? I'm multiplying with 10 and dividing by 10, no?
yes.
So this became 10 power 6. It came out 10 power minus 3. So inside it is under root 10 by 6, right? So root 10 divided by 4 into 10 power minus 3. So 0.8 into 10 power minus 3 radians per second square. That's your answer. Understood?
Yes, sir.
Okay. So your homework problems for today. Exercise 1. I think this is exercise 1 only. Exercise 1. Forty-five, 46, 47, 50, 54, 55, 57, 58, 59, 91, 93,